Let's look at lab assignment 6 then. It's here on the web under lectures. Here, lab assignment, mesh models. You can find the code under other material, mesh and texture lab base, and then there are two links here at the bottom, the Blender 2.6 download site and the exporter for Blender that we'll look at later on. But if you've Gradle imported the project files, you'll have a project that runs something like this. So we have this cube in front of us with this texture image.
I'm not sure this will show up on the...
It'll show up on the recording, but it's right now not showing up on the projector. So let's just change it up. Take the full screen
Desktop.
out. Yeah, desktop project. Here. No. I'm not doing the full screen there. I'm doing it in game. So this code here, where I'm asking for the display mode of the main display of the computer. So this should work on any computer, regardless of the resolution of your screen, and it should put the code into your resolution. Let's set it up like this.
Could you ask for it not to be in the main, but on the second screen?
Probably, but
it's neither here nor there.
like to only be on one screen, and definitely yes, but I don't know how. Just you can Google it, or you can just go through either the options here under this configuration. Maybe there are some options there, and you can look at if there are any more options here on the set display mode or something in the graphics. You can probably do something like that. For now, let's, since we have this in this resolution, I think it was something like this. Yeah. So okay, let's just keep it like this. So we have this cube here right in front of the camera. We have the pyramids as well and all that stuff, but let's not worry about that for now. And I'm going to see, okay, I might have already in the game file uncommented something that I wanted to have commented out. No, it's here. Okay, so the first thing that we want to do is basically to look at the mesh or the mesh model file structure. So to begin with, I'm going to take out the drawing of this cube and put in the model draw instead. However, it's not doing it properly now, so we simply have nothing in front of us. But if you have the cube to begin with, you know that everything should be placed in that spot. So make sure that the program runs first with the cube in the right place, then comment out the cube, uncomment the model draw, and then we can go here into the file structure under shapes G3 DJ model, and the main thing here is the mesh model itself. We can go through the structure here because we're using this mesh, which basically has vertices and normals. We have a list of materials which have different types of color, ambient, diffuse, specular, emission, opacity. To begin with, it depends on how your shader is set up. The shader that I'm working with now will just use the diffuse and specular, but you can set up your shader to use any or all of these colors. So we have the mesh, we have the material, and the rest is basically, the nodes is simply the structure in which we kind of access the different meshes and materials and parts of the model that we're drawing. So the main thing that we're going to do now is to look at the draw function. So I have this loader here, which I wrote, and simply goes to the JSON and loads up all of the data. So you don't have to worry about that. Not unless you want to add the loading of something else, either adding animations or UV maps or something like that. For now, let's not worry about the loading, but we want to draw this. So the idea here in how we draw this is we go through the list of nodes, and each node, look at this here, each node has the parts that are supposed to be drawn at that node. Then it has some rotation and some scale and some translation. So basically the different parts of the model are in different places relative to the center of this model. So the position of this model we decide outside of this in the code. So if we want to draw many of these models, we can translate them to different places, rotate them. But then while we're drawing the model, we also have to rotate and translate and scale to the different parts of the model. So while drawing this model, we want to translate to the translation. So we're going to have to do model matrix dot main dot add model matrix. Oh yeah, I don't know why that ended up. Model matrix dot main dot add. Oh, okay, it's because of this code above it. That right. Okay, so add translation we do first. And there we do node.translation.x, node.translation.y and z. So this should translate to the right part, or to the center of this node that we then draw the parts of the node relative to. This idea of having nodes and then the node having several parts, that's a bit more generic than we need. And in pretty much every case, the models that you make will end up having just one part for the node. So the node, in the case that we're going to look at, we have a sphere that has 6 other spheres attached to. So you can imagine that the main sphere is just in the center, and the other ones are translated to different places around it and then scaled down.
Sorry, what's a node? That's a point in the model, or?
Yeah, or the node, you can imagine the model, it's more like part of the structure of the model, the programming structure or the file structure of the model than part of the model itself. So a node is like if you imagine the model as a tree, and so the root of the model is just its center, and then you translate to a position where other parts are. Let's look at this once we have something on the screen so we can kind of see this better. So the idea of a node is just a part of the model. In this case, we don't have any children of nodes, so we just have a root, and then we have the nodes on that. So main dot add scale, node dot scale dot x, y and z. Okay, so what we're doing now is we're basically, well, the node can just view it as part of the model. So it's the file structure or the structure of the code that we have here, or the data that we have here, and we have several nodes. Each of these nodes tells us I have some data linked to me, some object, but I also have the position and the orientation and the size that that object is supposed to be drawn at. So the node has this information. So the node has the information of the translation, the rotation, and the scale. I'm using this function here, rotation quaternion, and there's no need to go deep into how that works. But that's the way so rather than storing the translations as angles that are rotated around a specific vector, it's stored in this way where you can use 4 numbers to basically represent any rotation matrix. Okay, so now we've basically gotten to the place where we want to draw this. So when we start drawing here, we're somewhere at wherever we want to draw this model. From there, we then translate and rotate and scale. So I start by pushing the matrix and I end by popping it so that these transformations don't kind of linger in our system. Okay, and then I set this model matrix. So I've set the model matrix I want to draw into. Now I need the actual data, the vertex data. So there are 2 things here. To begin with, we can do this part here, which which would be gx.gl.gl vertex attribute attribute pointer, attribute pointer. So here we have shader dot get vertex pointer. We are going to read these 3 and 3 together. They are of the type geofloat. They're set all together. If we were to set the U, yeah, well, never mind. It just means that if we could actually read both the vertex and the normals from the same list in this case, and just say read the first one starting at 0 with the stripe 3, so it's reading 3 and skipping 3, reading 3 and skipping 3, and then you could take all the other ones on the other side. But for now I've read this into 2 separate lists. So, and finally the pointer here will be our part, since we're doing this for each part of each node. Actually it's part.part, just because of the way it read into this. And this would be, no, not indices, vertices. Part.mesh. Sorry. So here are the vertices. Do the same thing for the normals, except we say shader.get normal pointer. So we're now just telling OpenGL from which buffers it should read and send that into our shader, into certain variables that we can then use in the shader. Same thing as we're already doing in something like the box graphic. You can just steal this code from here if you want and just change the vertex buffer and the normal buffer to part.mesh.vertices and part.mesh normals. Okay, so now we actually have some data that we're referring to. So let's see if anything happens. Well, we actually need this line here, which calls draw elements, and here we have the index list, which is indexing into the different vertices for different triangles. Okay, so we've done this. We've done this. This isn't to do anymore. The only thing we haven't done is set the material. So let's see if something. Okay. So here we have this object, and it's actually there. It is a sphere, and it has 6 other spheres attached to. And we can look a little bit at the file itself. Go into assets here. Look at models. We have test model here. So we have materials here which tell us how it should be colored. We have the indices and we have the vertexes. Just
this is a model. This is pure vertex data.
Yeah, this is just vertex data.
Wow.
But the stuff we have here are the nodes. And this node, first node says I have some ID, which doesn't matter that much, but I have parts. And the material I want you to use for this part is this material. So it's indexing into one of the 2 materials that we have here. Okay? And I want you to use this mesh part. And this mesh part is some index list into the vertex lists. So here's this part. Then I have sphere 1 to sphere 6, and I actually built them in this text file. So, or the first one I made in Blender, and then I simply copied them and just changed the translation a little bit. So you can edit things in here as well. But what it has is it says, okay, the first sphere is supposed to translate to -1, 0, 0, which simply means that it's going on the x direction a little bit to the left. and it's supposed to be scaled by 0.2, 0.2, 0.2. So rather than having the radius 1, it now has, it's 1/5 of the size of a full sphere. And the rest of them are the same, except they have different translations. But they're all using the same material, and they're all using the same mesh part. So they're indexing into the exact same vertex data. So we're saving space there. All right, so that's what the file looks like. And what we would like to do here is also for each part of the node that we're going to draw, we want to go shader dot set material diffuse part dot material dot diffuse dot r. Just copy this. Okay, so we're simply sending the diffuse color in here. I'm going to do the same for specular. So set material specular, and specular here, like so. So we're setting the shaders.
Making that.
Ah, okay, yeah. So this color doesn't actually have an alpha value, so let's just put alpha to 1. We'll look at blending later on. Yeah, this file structure doesn't have an alpha value. What it has instead in the material, rather than each color having a different alpha value, it just says let's just make one value here that we call opacity. Okay, I guess it's at the default value now being 1. But yeah, you can have opacity here, and then you just set that the kind of global or the main alpha value to that. Look at that better later. But for now, set material diffuse. Oh, double. Great. So, and okay. So same object, except now it has color. So that's all we need to actually be able to draw these objects here. So I'm drawing this object now, and this same mesh class that I have, if I go in here to create here where I'm loading this and say I'm gonna try to load test blob instead, then I just get a blob. And it's also just a model that I made in Blender.
So when you export it in Blender, you get this GPTJ file.
Yeah. So what you have to do,
To make the loading.
yeah, so let's just go back in here. So to begin with, we can open these two sites here. One of them is the Blender 2.69. So I would just take the Windows 64 exe here to install that. Then I go in here and I simply download the zip for this Git repository. Download the zip for it, and I take this folder here, and you can just see there are installation instructions here. So we simply take this folder here, IOScene G3D. We put it into what was the folder in?
You just already know it. Scripts and add-ons?
Yeah, scripts add-ons. So we can find that. See program files, Blender 2.69, scripts add-ons, and somewhere in here we have this IOScene G3D here. So we just put that there. Then we go into Blender. And in order to activate the exporter, we file user preferences under add-ons and import export. And we simply go through this list, and somewhere there we find libgdx G3D exporter, and we simply set that to something that we can export as. Save user settings, and from then on we can build whatever we want. We can go to file here, and we can go to export, and we can find libgdx G3D text format here. So now we can use this as an export. So if we want to make another file here, so if we want to look at Blender just a little bit,
You can explain what we're seeing in the scene, like that a camera.
this is a camera here, there's a light here, and because we're only interested in just exporting models and building our own scenes using OpenGL, then this whole scene idea isn't necessary for us. So what I've usually done is I've just removed the camera and this lamp, and actually we can just remove the cube as well, and just say we have this world now and it's empty. We can put, so this is basically a pointer to where things are built. Anyway, you can put that to somewhere, or you can simply change it afterwards. So if we go to add and mesh, we get a bunch of different things here. You can add something like UV sphere, which is kind of a latitude longitude type sphere, whereas the ecosphere is more like a 20-side die. Okay, so we have this object here, or we can build a different type of object. Add, mesh, cylinder. So we have these different objects. You can drag them around. You can go and find a Blender tutorial to do this more graphically. But in order to just get things done, you can go to this. You can select them here in this menu. So I'm going to select the cylinder. I'm going to go down to here and select object. So you can see if you hover over here which menu you're selecting. It says there object, and here we have the location, basically the translation on X, Y, and Z. And Z is set as up down in Blender, but it doesn't matter because it'll be translated correctly into our file structure afterwards. So we can just put this to 0, put it in the center, 0, 0. We have some scale here, so if we can put this to 0.2, this to 0.2, this to 3, have something like that. You can select the ecosphere, so let's just set that to the center as well. An important thing for the exporter to work correctly in this text format, this JSON format that we're using, is to make sure that every object that you have has a material associated with it. So let's select the cylinder. This part here is the material, and there's no material here now. So we can just make a new material, and we get this menu here. We go into the diffuse color and select the diffuse color here. Its intensity is simply a number that it'll be multiplied with. So if its intensity is only 0.8, you won't get the RGB values that you get in the end into diffuse will be 80% of what you have here. So for diffuse, it's alright to set this intensity up. Okay, and then we just select the color of this. Specularity, just have that white, and very intense. Hardness is the same as shininess. So we're setting the shininess here. Okay, so I've set some material to this. We can select the ecosphere, go into materials, and I believe we can associate the same object with, or another object with the same material here. So I can set the same material to it if I want, but I can also set some default material here, which is a new material, and then set that to some other value. So high hardness here, specularity. Okay, then we can do things if you want to. If we can take this here and scale it up a little bit, like 0.5. you can take an object here and we have object tools here. Where was the
Join.
we can join? No, I'm not looking for that. For one, you can here select smooth or flat shading, and it means that the normal list will be different between smooth and flat shading. Another thing we could do in some menu here was to actually kind of make more polygons on this ecosphere. So this looks like this. No, not this. Shade flat. It was in one of these tool menus where you could duplicate, delete, join, translate, rotate, scale, origin. Oh well. Normals here. Yeah, I'm not very good at Blender anyway. There's one thing I wanted to do, or just in order to be able to kind of work a little bit more with this, what it's called, tessellate or something like that. I'll search that. No, not what I'm looking for. Oh well, there was a way to kind of just dissect this so you end up with more polygons there. Go to sculpt mode. Oh well, you can kind of pull things around here, pull the polygons around, but it's more interesting if you actually have more polygons here. Anyway, let's not worry too much about this. What we can do now though is we can use the exporter, export to this format here, call it blob2, and put it somewhere other than this. Let's try this. Export. See if we got it now here. We have blob2 here. Let's see if we can stick that into the models. Change this to blob2. And see if we actually read this. Yeah, okay. So there it is. All its glory. So rather than me trying to teach you how to model in Blender, you know, just find tutorials or do whatever you want, or find Blender models online, import them, and then try to use the exporter to export them out and see if the materials and everything come out right. But as soon as you start doing more complex things, then probably it won't be supported in the text format that we're using anyway, but you can at least get some interesting stuff done. And we can, for instance, go into object mode here, do smooth shading on this, export it again, pick up the latest version, stick it in here, and see if, well, didn't I copy the correct version? Blob2, paste, yes, and okay, so now we have smooth shading on that. But obviously it's still a very low polygon model, so but if we use a UV sphere rather than an ecosphere, we can get different results. Anyway, are there any questions on this, the mesh idea? So this is basically all we need to be able to set up different models and import them.
Do you texture the model in Blender?
You can texture the model in Blender. I'm not sure how the exporter handles the UV coordinates, if it can export them. And then you can read them in, and you can just go through how I'm reading in the other coordinates and see that. It's basically all set into the same list, so you have to read it out of the same list. But right now I'm not taking UV coordinates from the models and setting them up there. So if you want more complex stuff, either try to figure it out in this format or just go ahead and learn how to read in a more robust format for meshes.
How would you...
Or we can just texture map them afterwards ourselves.
Yeah. There's a special texture map for like a blob.
There are a few texture maps, and what you'd use for a blob like that would probably be either a cylindrical or a spherical texture map. And we can look at how that works. I want to look at the textures a little bit now. So what we have now is basically we've set up the model loader and the model display, the mesh model, so that it displays these models. And then you can just go ahead and build your own models here. I want to comment this out again in the game class. Go a little bit down here. And put this textured box in again. So okay, here we have this box, and the texture coordinates are pretty weird here. So what you need to do is just go ahead and play around with these texture coordinates here. For instance, this one here is going from 0 to 2, even though the coordinate system of the texture itself only goes from 0 to 1. And what is happening is we're just repeating this. And actually set this up here, somewhere in this. Remember if it was in the shader or if it was in the display function here. Maybe it was in the shader file. Graphics, shader. So whenever we're asking to use a texture, I call this as well. So I'm simply saying how OpenGL has different ways of wrapping the S texture if you go beyond 0 or 1, if you go lower than 0 or higher than 1. And I'm asking it to simply repeat the texture. So it'll just, if I go take the texture coordinates further than 1, simply you can see this side here, this one, where we simply have a repetition of the... Okay, but we already have a video from a lecture where we're setting up these different coordinates. We can also just take the same coordinates here and set them here and here and see what happens then. And we'll simply be setting the same sides to different parts of this. And one of them obviously is this side, which is going from 0 to 1. Which one is it? Yeah, this one here. So you can then go ahead and exercise yourself with setting the right texture coordinates to get 1, 2, 3, 4, 5, and 6 on different sides of the die. And if you want to set up some other texture image, you can simply put whatever PNG here. A JPEG should work, but I've had good results with PNGs. And you can just go ahead and set this again to, I think one of them was, yeah, this one. Just like this. And let's just copy this over all the rest. 1, 2, 3, 4, 5, 6. I think they should work. 1, 2, 3, 4, 5, 6 sides. Should all have the entire texture now. And if we then go into the game and just load another texture image. Oh, I lost here. Was 2K. big and detailed texture here. Okay, then we simply have another texture image here. Okay, but this, however, is a spherical map. This texture image is textured as or is built as a spherical map. So it doesn't really fit on the side of or it doesn't look well on the side of a cube. What we want to do is we want to take this and we want to wrap it around a sphere to make an actual planet texture. So, would you like me to walk through how the textures are working in the shader and stuff, or just? Okay, so what we're using here in the shader when we set the texture is we've loaded this into this texture, and we use this to bind the texture. And there's some OpenGL functionality behind this bind here. What's happening is basically that OpenGL, or this texture, has already saved the texture data, the actual texture data, and it's received from OpenGL some number, just some handle to that texture data. And the texture class that we're using, which text is an instance of, knows what that ID is. And we don't really care about the ID, we just care that it's bound when we want to bind it to this texture. But the number we're sending in here is called the texture unit. And we can have several texture units, and we can use many texture units at the same time. So at the same time, when running through the shader, we can bind a diffuse texture to one texture unit, a specularity texture to another, an alpha texture to another, a shininess texture to another. And so right now we're saying bind this texture to texture unit 0. Then we tell our shader to use 0 for its diffuse texture location. And that is referring to, no, not this. That is referring to this sampler 2D variable here. So sampler 2D in this case is just an integer that tells us which unit is bound to. But the sampler 2D is a special case of an integer, and we use it through this function here. So we say we have some coordinates here, some vec2 uv, and we have this texture unit, and we want to take these coordinates and sample the color from the correct pixel in this texture, in the texture that this texture unit handle refers to. And when we call bind in OpenGL, we're simply saying OpenGL, here is the actual data that is supposed to be bound to this texture unit. So when we draw one object, texture unit 0 will be bound to the Phobos moon texture. Then we draw some other object, and that same texture unit 0 will be bound to the dice texture. And then we can draw all these different objects using the same texture unit, but we're making that texture unit refer to different textures at different times. So right now we're just using one texture unit. In the lecture, I showed you code where I had two texture units. I was using a specular texture and I was using a diffuse texture. We're using them both at the same time. The UV coordinates, they are used first in the vertex shader. And so I have this attribute here, the same as the attribute position and normal. Here I have a vec2 attribute for the UV texture, for the UV coordinate, sorry, the UV map. So for each position, vertex, there is a normal associated and there is a UV coordinate associated. And this will be read from the lists in parallel and all sent in. So each of them, the only thing I do is I set this varying vec2 VUV, and I set that to the attribute AUV. That's the only thing I do in the vertex texture, because I don't want to sample just for the vertex. I want this interpolated over pixels, so that in the fragment shader, when I'm doing this per pixel, then I actually do the sampling and ask for the color of the pixel there. So in the vertex shader, this is all we need to do. Just send this on into the pipeline so that it be interpolated per pixel. In here, all I do with this is ask for the color. And I only do this when I've told my shader that I'm using the diffuse texture. This is basically a floating point that is 1 if I want to use it, 0 if I don't. And so I say if I'm using textures, then I want my material diffuse to be this value here. This value that I sample from the texture data. If, however, I'm not using textures, I want the material diffuse to be the material diffuse that's being sent in. So if we look at how this runs again, here on this cube, I'm using the texture as the diffuse value. Here on this pyramid, I'm using some material I sent in there. some color, and here I'm using another color. So on both the pyramids I'm using the material diffuse value as the material. However, here I'm using the texture instead. You can also multiply the two together if you want both to have an effect, but in this case I'm just using the diffuse texture. Okay, so that's how we sample this. And what we need to do in our program, this sampling happens fairly automatically because it's just interpolating over the pixels and sampling at the correct location. What we need to do is to set up the UV map for each object. So in our case here, we're just mapping the corners to the corners of the texture. Earlier, we were referring to these different locations within the texture, like 1/3 and 2/3 on these scales. You can just try putting in weird numbers here. You can also just put in something here and see what happens. One of the sides here will probably be, that one. Pretty wonky there. It's hard to see here in this light. So you can just experiment with numbers here. What I want to do is to go into the sphere graphic class and see if we can texture map that. That's going to be a little bit more complicated than what we did before. But if we look at this code, we can see that the base of it is 2 loops. One of this loop is incrementing this angle that I call stack angle, which is basically the longitude lines of a globe. The other loop is incrementing this number called slice angle, which is the latitude lines of a globe. So what we basically need to do is we need to find a way to say I'm going to take the XY coordinates from the texture, or the UV coordinates, and I'm going to set them in one direction, run them from 0 to 1 while I'm going 360 degrees around the globe. The other one I'm going to set from 0 to 1 while I'm going 180 degrees from the bottom of the globe to the top, or from the South Pole to the North Pole. So, you can help me out here. First we need data. So we need to set this up so that we can draw it the same as box graphic. So let's just draw solid cube here and see what we're missing in the draw function here. Okay, so alright, we have some texture that we're sending in here. We've already set that up. We need a UV pointer here. Okay, we already have this set up. So the sphere class, we don't have any UV buffer. So that's one thing we need. So we'll build a float buffer here, call it UV buffer. And I guess the first thing we need to decide is how big that'll be. So here I have this array, which is for the vertices. If I imagine I need as many UV coordinates as I have vertices, how big should the UV array be? Maybe just do another float array, call it UV array, equals new float. Okay, can it be the same size? Because the UV coordinate is 2D, whereas the vertex coordinate is 3D. Yeah, 2/3 the size, so let's just change 6 to 4. So stacks times slices plus 1 times 4, because we're kind of doubling all the vertices because of the way we're drawing this. We could set this up as draw elements with an index list, but let's not waste time on that now. We could just as well do that with a globe, and you can look at how that looks by making a sphere the same as this and exporting it into the file format. Alright, so now we have our UV array. Now our idea is that inside each part here where we're saying array.vertex count blah 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 does something, we kind of need to do the same thing. For UV array. Okay, so we're doing this vertex count thing, except now we'll probably do it times 2. So we're doing 2 vertices in each loop. vertex count times 3 because we have 3 numbers for each vertex. And then it's going +1, +2, and up to +5. Okay, this needs to equal something. Why do you do this? Okay, +1 equals something. So what I'm doing here is I'm saying the coordinate here, this texture coordinate is the texture coordinate that should be mapped onto this vertex, right? And this texture coordinate is the texture coordinate that should be wrapped onto this vertex. So we might as well do it like this and say, okay, here we have a vertex that is using the sine and cosine of slice angle and stack angle here. So this is a bit complicated what we're doing here, but the only thing we need to know is that in one direction we're basically using the stack angle. So the stack angle starts at, okay, stack count times stack interval, yeah, okay. So what we need to do is basically kind of spread this angle going from 0 to slice count, or it's basically the slice count that we're interested in. So we need to spread this from 0 to 1. So we have slices plus 1 here, which should, when we're there, when slice count is at slices plus 1, or is at slices, we should have 1. When slice count is at 0, we should have 0. So how can we set up that interpolation? So we're going u is this, so the v, the second coordinate, no, that's doing the stacks. The first coordinate is doing the slices. Okay, so we can say slice count divided by slices. How would that look? Maybe this could be float actually. When slice count is at slices, this will give us 1. When slice count is 0, this will give us 0. And in between, it will give us something from 0 to 1. So we're going from 0 to 1 as we take the slices from 0 to slices, to kind of max slices, or how many they are. So we can set slices here to any number. Okay, so we're using slice angle plus stack interval, which would mean that down here we want to do slice count plus 1, right? So we're kind of just looking one ahead. Let's see, doing that in the slice, no, we're just doing that in the stacks. It should be the same. It's the stacks that we're looking one ahead in. Okay, so we should be able to do the same thing here. Float stack count. If you feel I'm doing this wrong, let me know. Stacks. Yeah. And then here we would use stack count plus 1 because we're looking one ahead. And that's why we're going all the way up to slices in this loop. So we're saying it's less than slices plus 1, which would be the same as saying it's less than or equals slices. But we're always looking one ahead in the stack, so we only go up to almost stacks. But in the last iteration, we actually go all the way there. Okay, so let's see. let's see, vertex count plus 2, this is happening here. Okay, then we need to actually do the same thing here for vertex count times 2, new float buffer. So this is UV buffer, put UV array. Okay, so now we have some UV buffer. Let's maybe draw an actual sphere. Let's go into game here, display function, and instead of box graphics draw solid cube, let's do sphere graphic draw solid sphere, shader and text. See if it's anything like it should be. Definitely not. Okay. Cool though. Okay, let's look at sphere graphic again.
Like it's only doing stacks, not slices.
Slices, stack count, stack, slice count. We're reading these 2 and 2 together, not 3 and 3. So we're going up by slice count, which should end. We're doing it the wrong way around. Maybe this stack count plus 1 not being inside. Now we're talking. How does this look? Okay, what I'm going to do now is I'm going to ask it to stop constantly rotating. And I'm also going to set the light position to where the camera is again, so we can just look at this. No. Set the light position to the camera. And I'd actually like to set the specularity to 0 so we don't always have that. Okay, now we can look at it. So, how does it feel to you? Like it worked? Yeah, even the top, which you'd imagine kind of just, and it does. It ends up in these really, really tight triangles that come into a single point here. Yeah. But the texture map is designed to texture onto a spherical map exactly like that. So it works. So here we have a spherical map on a sphere. And it seems that it works all the way around. And you can just go on, but here we can see it actually. Here the mapping is a little bit off. At one of the poles, but not on the other pole. So I'm gonna blame it on the actual texture mapping rather than the UV map that we're building. It doesn't matter. If you have this in your scene floating around in space with a bunch of other planets, it looks super nice. Is this the other pole? No, this is the same pole we were looking at, right? Yeah, no. Seems legit. Okay. But obviously here we're building the sphere itself at the same time as we're building the sphere map, which is nice. And so we can wrap this around a sphere. What we want to do if we want to do a spherical map onto an irregular object is we kind of have to, rather than here, we're actually we're incrementing these angles. We're taking these angles from 0 to 180 degrees or from 0 to 360 degrees. We're basically going around this, and at a regular interval we're picking a new texture coordinate and a new coordinate for the vertices. If we want to spherical map an irregular object, we have to kind of do it the other way around. We have to be able to take the vertex and figure out the angle, and from that angle we can figure out where in the spherical map we are and thus which UV texture coordinate we need.